This illustration deals with conductor construction and application in accordance with NEC 310.4 and of course Table 310.4. Now notice the purpose of change. Tables 310.4a and 310.4b have been relocated from the old table in the 2017 NEC, which was Table 310.104A and Table 310.104B, and as previously just stated, that was from the NEC 2017 edition. Article 310 now contains about 12 tables. That's what's in 310 right now. But notice that I kind of call this table the conditions of use when you're using certain types of insulation. Like if you look at the letter type, that's the first column to the left. And then in column 2, you see it's insulation. And in column 3, you have the maximum operating temperature of this THHN is 90 degrees C. And we know that in 110.14C, you can derate from the 90 degrees C back to a usable 75 or 60 degrees C, depending on how the breaker and the equipment and so forth is marked. Now, column 4 says, yeah, this is dry or wet locations only. And then the sizes these conductors come in from column 5 is 14 through 1,000. Now, notice that THHN is 600 volt rated, and it's used in hot areas. Now, we say 600 volts, you could put it in, say, 120, 240, 120, you could use it in 277, 480, 480 volt underground, etc. Notice it's a nylon jacket or equivalent. Now, usually this is used in hot areas. I'll give you an example. Teaching up on the scope of Alaska, you know, it can get up to down below 55 below zero up there. And the OSHA up there asked me, Stallcup, could we use THHN up here in this cold area? And I said, well, yeah, you could use it. And then the next morning we had breakfast, as we did every morning, and he took me outside, and he'd taken THHN and strung it from building to building, they're close, in XHHW. And he left it all night long out there in that below zero, you know, temperature, way below zero. And he took his clients and he started hitting that THHN, and it just started cracking and breaking the insulation. He hit the XHHW, nothing happened. And he said, you still think we can use the THHN up here? And I said, yeah, inside the building. But I really didn't realize that THHN could not be used on the slope that they use strictly XHHW. Now I'm talking about the slope of Alaska. So if you drop down to this XHHW, then notice it's flame retardant, moisture resistant, thermal set. It's good for 90 degree or 75. It's dry and damp location, and if you use it in a wet location, it's 75. See? And it comes in sizes 14 through 2,000. And the XHHW is usually used in these real cold, severe areas because it can withstand the cold, see, is what they were telling me. So we would kind of use that there. Now, if you drop down and look at the first column and look at THW, it's flame retardant, moisture, heat resistant, thermoplastic, 75 degrees C, and dry, damp, and wet locations, but 90 degree if you use it in electrical discharge lighting equipment and areas like that, see. So that kind of gives you a feel for where THWN could be used. And if you wanted to go over and take a look at your 310.6 and 310.10, then you'd notice it's one of those W rated that could be used in a wet location. So it kind of lists where it can be used and where it can't. And then notice usually they use it in these wet locations and very cold type areas, but it's using wet mainly in the heat, about up to 75 degrees C, and it's a thermoplastic. So this kind of gives you the characteristics of use of conductor insulation. And in the 2017, it was table 310.104B as in boy, but in the NEC edition 2020, it's renumbered to 310.4, and that's a little bit of the insight to this to the renumbering. And then notice the note 1 for conditions of use of the insulation, C310.4 in tables 310.104A and B. And then for existing tables 310.104A and B, they've been relocated to 310.4, and that kind of summarizes this the relocation renumbering of this table. And then the tables for over 1,000 votes from 310 have been relocated to the new Article 311.